Nowadays, digital test meters are really cheap. You can get a not bad one for 20 or 30 bucks. Back in my days when I was younger, a good one cost $200 or $300. A lot of people don't know how to use them but own them, so I'm going to give you an idea of how to use them around your house and your shop. So I'm going to give you sort of a basic tutorial video just to get to know the normal things you would want to use your test meter for around your shop or around your home. First of all, you want to know what range to set your meter for, so you have to have an idea what you're expecting when you're testing something. This means DC volts, the wiggly line means AC volts, the omega sign means ohms, the picture of the music sign means continuity tester. It just every time you test the two ends of something, it means it'll beep or chime for you. And A means amps. Most people don't have the amp tester part of their meter, but that's fine. Most times you don't need it anyways. So if you're going to test your house current or something like that you know is AC, set it to AC scale. And some meters are not automatically adjustable. Mine is, so I just set it to AC and it will measure any AC voltage. But if it's not automatically adjustable, you have to try to guess what the voltage is supposed to be and set it for the correct range. So this is going to be around 120 volts. So it's hooked in, and it's 122.5 volts, so all's working well. AC has no polarity for positive and negative, so it doesn't matter which way you stick these in. DC does, so if you have an analog meter and you hook these up wrong, the needle might not move. It might try to go the wrong way. On most digital meters, they'll just figure out positive and negative by themselves, and they'll say whether it's positive or negative on here depending on whether you have it hooked up right. So battery's hooked up, and it says we have 12.6 volts, which is good. Now the confusing thing about batteries is even dead batteries often show close to 12.6 volts, or a battery that's been on charge all day or just come out of the car but still won't start the car, or just came off the charger that still won't start the car, still might show the correct voltage. But the plates inside can be all sulfated and so rotten that it's got virtually no amps left to start the car, so it's actually confusing testing car batteries. Also, to test any kind of flashlight or portable device battery or a cell phone battery or something like that, or a camera battery, also have it set on DC volts position. These all little 1.5 volt batteries are sort of considered good if they have more than 1.4 volts. Brand new, they might have up to 1.6 volts. If you have a digital display thermostat in your home to control heating and cooling, very often people call me to fix their central air or their furnace and wonder why it's working intermittently or not working at all, yet the display works on their unit, but the outside unit in the furnace doesn't work. Well, they have these little pen light batteries in them too. Most people don't even know that, or they have a 9-volt battery. And so even though the device appears to be functioning, you touch the buttons, it changes the numbers and everything, very often the batteries are bad to know. So before you call a repairman, always check the batteries in your digital thermostat so that you don't waste money on a service call. You can't truly check an electric motor with one of these meters to see if it's good or bad, but if your electric motor is completely dead and acts like nothing's happening, not even a moan or a groan, well, most of them have what's called an overload trip device. A little black box in them someplace with 2 wires going to it, so when the motor gets hot, it cuts out. Sometimes the little terminal is burned off. Sometimes these things go bad. They can easily be tested. You set your meter for ohms, and it should show, if it's good, hardly any ohms. That's showing like 0.1, 0.2, 0.3. That's telling me that's got a good overload, so if the motor doesn't work, it's another problem. You can use your motor set on a voltage position just to see if there's power coming to it. Every compressor, like on a fridge or an air conditioner, always has 3 pins. Well, if your air conditioning compressor or fridge compressor is not moaning and groaning, not making a sound when it's trying to start, well, the first thing you want to do is check if there's power going to it. So you would set it to AC volts, take the protective cap off, and start from the overload, touch it to here, and then touch the other lead to the different pins and see if you have the correct AC voltage that your house or shop is putting out. So if the voltage is correct and it's coming to those pins and the compressor is not doing anything, The next step is set your meter to ohms. Turn the power off to your unit, completely disconnect it from the home or shop. Unhook the wires going to the pins, at least the two that aren't connected to the overload. Then while set to ohms, check continuity on your overload. Your overload always has 2 pins. It should show very low ohms, which means it's good. Next step is, with the wires disconnected, unlike I have here, touch one lead to ground, power is turned off, and you're checking continuity to ground on each terminal. You should not get a reading on your meter. There should be no way electricity is coming from these pins and touching ground. If it is, the compressor is shorted. Next thing is, go across any pair of terminals until you've tried them all to see what reading you get in your meter. Each way you try them, you should get a low ohms reading. If you find 2 pins or all the pins have no reading on your meter when you're continuity testing them, well then you also have a bad compressor, an open circuit compressor. This method definitely doesn't tell you 100% whether your compressor is good or bad, but it helps diagnose electrical problems when you're trying to determine what's wrong with your unit. See, the compressor can be seized up or have partially shorted windings or overdrawing or all kinds of different problems, but at least now you've diagnosed why it seems to be dead. If you have one of these little AC to DC adapter power packs, well, they're easy to test too. Just set, most of them are DC output, so just put your lead up there, another one in the hole, set it for DC, and check the voltage. Should be very close to what's written on the label. Of course, car fuses are easy to detect. You can put them on continuity test, which gives you a beep if they're good, or put them on ohms and see if they give you a very low ohms reading. When they're installed in the fuse box of your car and you try to diagnose electrical problems, they always have a bit of the active end, which is connected to those terminals, sticking out, so you can use it as a test point for your meter and set it on DC volts and go along and test if both sides of each fuse have a correct around 12 volts on them in the circuit. When the key is turned on, usually all the fuses should have 12 volts on both sides, and when the key is turned off, only a few fuses will have 12 volts on both sides. If you want to check one of these micro switches, well, they're marked NC, NO, and C. C means common, and then that goes to a swinging arm which sends power to one terminal or the other terminal. NC means normally closed, so if the button was not pushed and you test it with your meter, it would beep or show low ohms. And the other one that says NO, normally open, would show nothing. Then you push the button and click it again, and it reverses. One shows continuity and one doesn't. That's how you test if one of these are good. Now, home fuses sometimes are easy to see if they're blown, and sometimes without a trained eye you can't tell. So a meter is very handy to have. 3 kinds of fuses. The old-fashioned fast blow fuses. These are best to be used on high amperage devices like heating elements, ovens, stovetops,